Hello, Gerald.
Hello there, Richard. How are you?
I'm good. How you doing?
I'm all right.
All right. Well, thank you all for joining us tonight. It's another virtual telescope viewing tonight. We're at what, 98% humidity or something, or
Something
partly
like that.
foggy.
Yeah, it's
Yeah,
it's
yeah,
really
yeah.
high.
But I am actually here with the usual star of our show, which is Nellie, our 36-inch research reflecting telescope. Gerald, you're at home tonight.
Yep.
I was going to be at home, but I had to run up here to take care of something else, so I figured I might as well give people live views of the telescope, even though we're
Yeah.
not going to have live views through the telescope. So when it gets too humid, usually that means we can't see the sky. And even if we could see the sky with that kind of humidity, we would be collecting water more than photons. And that would make a mess in the telescope. So whenever it gets above 85% relative humidity, we can't use the telescope. And when it gets above 90%, we can't use the other telescopes here. And that's the kind of night we've got. So we've got some other stories and news for you. But before we get started, I want to remind everyone that the Chabot Space and Science Center is still closed, but we're getting close. About a month and a half from now, we're going to be doing our reopening. And if I'm not mistaken, Gerald, that's going to be on the 13th and
12th,
14th,
12th,
12th and
12th of
13th.
12th of starting the weekend of the 12th of November.
The
Yeah.
weekend of the 12th. Does that include
Right.
Friday or is it going
I
to be
believe it includes Friday. Yes.
got it? Okay, so the 12th, 13th, 14th, that's our big weekend when Chabot Space and Science Center is going to reopen. We will have all kinds of events happening that weekend, and we'll talk more about those as we learn more. What I do want to mention for those of you who have participated in the past or may be interested in participating, the following week on the 19th, we're going to be reopening the Telescope Makers Workshop. And that is a workshop that has been held every week for the last, I don't know, like 90 years.
Almost.
Something like that, something
Yeah. I
like
think
that.
it goes back to 1947 or something like
Yeah, I
that. Yeah.
wasn't around then, but in more recent decades, I have been involved in that, and we teach people how to grind and polish telescope mirrors for reflecting telescopes. And you could build your own high quality telescope, nice scientific instrument that will last you your entire life.
Yeah.
You won't
Yeah.
make one as big as this one, but you'll make maybe an 8-inch, 10-inch, 12-inch telescope, and learn a lot in the process.
Yeah,
So that's
don't be fooled. Just because you're making it yourself doesn't mean it's a good telescope. In fact, quite often we have found that the homemade telescopes actually perform better than some
yes,
commercial telescopes. So it's definitely worth your time and effort to look into doing that.
yep, and yeah, we try to make sure you're going to walk away with something better than a store-bought one or a commercial one. So anyway, that's uh, that's the news from Chabot. Um, if we had clear skies, we'd probably be spending some time on planets. And I want to get started by showing you a couple of images that one of our East Bay Astronomical Society members took just the other night from Fremont, of all places. And give me a second here, and I have to switch over. There we go. All right. So these two images were taken by Gert Gottschalk, who is a longtime East Bay Astronomical Society member and is also our director of instruments for EAS and coordinates any repairs and maintenance on our, at least on our refractors. Leah and Rachel, and occasionally on Nellie as well. So the method he uses for these types of photographs are to take video and then go through the frames, either manually or using some automatic scripting, to find the sharpest individual frames, and then separate those from the rest and stack them up to create a high resolution image. And the image on the left of Jupiter is actually 5,000 frames whittled down to the best 500. And that's true for the Saturn image as well. So he'll take the 500 best frames from the video camera, and he uses a piece of software called AutoStacker to stack them up and play with the resolution settings. So anyway, I thought these are very nice, and it kind of gives you an idea of what you can do with a telescope in the city and a video camera.
Yeah, yeah.
These are not bad. But
now, both these planets are up tonight. If you happen to be somewhere where the sky is clear, I see some people from Mount Shasta area and Stockton, and even somebody from France. So if you happen to have clear skies, you can see both these planets. If you look toward the southern sky at about 9 o'clock at night, you'll see a very bright star about halfway between the horizon and straight overhead. That is Jupiter. And then if you hold your hand out at arm's length and spread your fingers a little bit, put your thumb on Jupiter, your little finger will be on Saturn. Saturn won't be as bright as Jupiter, but it will be brighter than most of the other stars around it. So that's the way to find them. And they will be in the skies for a couple more months yet.
Great. All right. Well, I'll turn it back to you because I know you got something to show us.
Well, just take a look again. Whoops. All right. Well,
I can
put it back up for just a second here. If you take a look at the image of Saturn, that's a pretty clear image. And Richard just described the work it takes to do that. Well, there's a guy named Damian Peach, who we've talked about many times. He's just a really excellent astrophotographer, and he can put together some pretty good images using fairly modest equipment. So I'm going to share an image, a composite image that he made recently. This was put on APOD, the astronomical photo of the day. So let me just share that. So these are all images taken by Damian Peach, and what he's done is shown you the progression of the angle of the rings over time. Saturn takes about 30 years, just under 30 years to orbit the sun. And it's the ring plane maintains a constant orientation relative to the stars. So from our point of view, the ring plane angle seems to change from one year to the next. So what you're seeing here is the progression from maximum tilt in one direction to maximum tilt in the other direction. And this would take about 15 years to go through this whole progression. Now, right now, we're kind of halfway in between these two right here, if you remember from that previous image. But as we continue on, we will get the rings angle will get less and less and less. And he didn't quite catch it exactly edge on, but he got pretty close with this image here. If he were to catch it exactly edge on, which only happens for a day or two, the rings literally disappear. You look through the telescope and you see the planet Saturn and you don't see the rings. And then the tilt continues as Saturn continues its orbit around the sun and eventually reaches the maximum tilt in the other direction. Now again, this shows the progression over a 15-year period, half of Saturn's orbit. So it goes from maximum tilt in one direction, 15 years later, maximum tilt in the other direction. And then 15 years after that, it's back to where it was in the beginning. And it's made one complete orbit around the sun.
Well, I'll tell you, it usually photographers light catching Saturn at that maximum tilt, so you could see the Cassini division and the Encke gap and all those other features of the rings, but it's pretty compelling to try to capture that minimum ring or the disappearance of the rings that you're describing, because that would be quite a challenge photographically to do that.
Right, right. Well, what I think is really amazing about this series of photos, it took him 15 years to do this.
Yeah.
And you look at these images and they all are pretty much exactly the same resolution, same color balance. Everything is the same, as if it's a scene from a movie rather than something where he's taken it over 15 years, different viewing conditions, even possibly different equipment. And yet he gets this nice, very well balanced set of images. I just think it's pretty amazing that this guy is able to do this stuff.
Yep.
All right.
Speaking of gas giants, there was an interesting story I saw this week. One of the mysteries of Jupiter was to try to understand why its upper atmosphere was at a higher temperature than expected. And we've sent several spacecraft to Jupiter over the last several decades, and the temperature readings of that upper atmosphere are kind of high. And the new theory on why that is the case is that it's actually being heated by the aurora that Jupiter produces.
Yeah.
And Jupiter has an aurora much like we have an aurora borealis. I'm not sure what you would call it on Jupiter, but it's the same phenomenon where you have solar wind being captured by a very powerful magnetic field and creating a glow in the atmosphere. And it's, in the case of Jupiter, it's acting like an electric heater.
That's right. Yeah. What happens is the solar wind is captured by the magnetic field. The magnetic field then channels the solar wind particles, which are, hot plasma and ionized gas, toward the poles. And when it reaches the poles, that's where the magnetic field lines drop into the planet. And so these particles drop in, and as they enter the atmosphere, they begin to glow. And so that's what you see as an aurora on Jupiter. And of course, we see it here on Earth as well. And it's the same phenomenon here on Earth.
Well, I can actually show a picture of this. Let me share my screen here for a second. This is a Hubble image of the aurora on Jupiter.
Yeah.
And you can see this is no small phenomenon here. I mean, Earth would be, a bit larger maybe than the hand cursor here that I'm showing. And this is a pretty extensive area of Jupiter that's glowing from this aurora.
Right. Yeah, Earth, Jupiter's diameter is 11.2 times the diameter of the Earth. So the Earth would fit well within that circle of the aurora there.
Yep.
In fact, it would fit inside the great red spot that you see down at the bottom of the frame.
That's right over here. Yeah, this is a pretty nice image. So, if you've got a good space telescope, it even looks better than Damian Peach's images.
You're a troublemaker.
I always, whenever possible. All right.
Well, we have another space telescope going to launch later on in November, or actually December now. It's December 18th.
Now.
Yeah, December 18th. The James Webb Space Telescope will be launched. And that will head out to L2, the point where Earth's gravity and the sun's gravity are in balance. And we will have a new space telescope. So we're kind of looking forward to that. Of course, it's going to take 6 months after launch for it to get out to where its final parking spot is and unfurl and get testing. But I would suspect that right around the 6-month point is when we're going to start seeing some really spectacular imaging coming from the James Webb Space Telescope. Finally,
if I recall, the unfurling is actually going to be happening pretty soon after it leaves Earth's orbit.
Right.
And so the most exciting news is going to be whether it is successful in unfurling the 300 some odd cables, gears, and wheels that have to be actuated in order for this thing to properly deploy. And that's what all the engineers are losing sleep over, because they've been, working on it for more than a decade to try to get this thing to really, it has to be 100% reliability.
Yes.
And how many things in our lives operate at 100% reliability?
Yeah,
not too many.
I was actually surprised they were able to eventually solve this problem. The company that I used to work for, we had been approached by Northrop Grumman about making the sunshield materials. The sunshield is the size of a tennis court. It's got 5 layers with separators in between them. And it has to be able to be all balled up for launch, and then it has to unfurl this full, size of a tennis court. And that was quite a challenge, and also meet the weight requirements. Ultimately, we weren't able to do it, but they did find somebody who was able to do it. And it's just going to be really interesting to see if that actually works the way they hoped. They've tested it many times on the ground, and it looks like it's going to be successful, but in space, you never know. And of course, you can't go back and fix it if it doesn't work right, So.
Yeah, not in this case.
Yep.
Yeah, so every time they made a change to the spacecraft, let's say they decided that they needed a larger pulley, right? Or they needed an additional cable, they would have to do what's called a regression test of the entire unfurling operation. And that means they add this new component, they fold it all up again, and then they go through the entire sequence over and over and over again to make sure it works reliably with that new part. And if they have to we need to shave 1/8 of an inch off, and they'd have to go through that
Go through
whole
the
process again,
Yeah.
because that was the rule. You make a change, you have to do the regression testing, and that's why there were so many cost overruns. But it's also the reason why, if this thing, works, you can say that it's really because of this very conservative regression testing regime that they put in place. So right now, the Space Telescope is in a container going through the Panama Canal.
Yep.
And it's going to be launched from French Guiana, and it's going to meet its Ariane 9 rocket and capsule there at the spaceport. So we will be giving you news and photos as we learn more.
Right. Again, the launch date right now is scheduled for the 18th of December. So that'll be something we can look forward to.
What is that, like 6 years late?
Well, my recollection was it's actually more than that. It's 8 years late.
8 years late.
Yeah. The original launch date was 2013. So yeah, and they've it's been a long haul, and it's been difficult, but we're finally there, and that's the good news. And I'm looking forward to seeing some great images, infrared images of the interiors of nebula where star forming is occurring, looking deep into the galaxy, looking at parts of the galaxy we haven't been able to see before. So it's going to be pretty spectacular. So
I think that on the launch date, we're probably going to have some kind of live coverage from Chabot as well. I think that was the plan to do that. So we'll have some kind of program to, we could have a nail biter, which is Always the case with these rockets. Right?
Speaking of Lagrange points, another mission that's going to launch later on this fall is the Lucy mission. And the Lucy mission is a mission to send a spacecraft to visit Trojan asteroids of Jupiter. So Jupiter orbits about a little over 5 times farther from the sun than the Earth. Jupiter takes about 12 years to make one orbit of the sun. And Jupiter has Lagrange points just like the Earth does. There are 5 Lagrange points, whether you're talking about the Earth or Jupiter, there are 5 Lagrange points. 2 of those Lagrange points are on the orbital path of Jupiter, but one is 60 degrees ahead of Jupiter and one is 60 degrees behind Jupiter. So if you imagine wherever Jupiter is in its orbit, 60 degrees in front of it is a Lagrange point, and 60 degrees behind it is another Lagrange point. And a Lagrange point, again, is where the gravitational pulls balance so that an object at the Lagrange point can actually stay at the Lagrange point for long periods of time without any orbital adjustments or anything. Well, as it turns out, there are a lot of asteroids at the Lagrange points for Jupiter. And so the Lucy mission is a mission to go explore one of the Lagrange points. And I can't remember whether it was L3 or L4, but it's, or L4 and L5. But it's one of the two. And they're going to launch from Cape Canaveral. And that's going to be I think on October 16th is the launch date. And they will head out. It will take a couple of years to get out to Jupiter or to the Lagrange point, but then they're going to get out there and study some asteroids in the Trojan asteroid region.
It is the assumption that the type and composition of those asteroids are going to be fairly random and are going to reflect the kind of the cross section of different types of asteroids that cross Jupiter's path?
Good question. That's one of the things that they're trying to find out. If you look at the distribution of asteroids in the solar system, you have what we call the main asteroid belt, which lies between Mars and Jupiter. There's a broad region there where you don't have a planet, you have a whole bunch of asteroids. And it turns out that the location of asteroids within that region, that's a very wide region, actually somewhat defines the composition and the structure of those asteroids. So we find that a type of asteroid called a carbonaceous chondrite is an asteroid that's kind of got a very heavy base matter, has quite a bit of water in it. Those tend to be on the outer part of the main asteroid belt, whereas asteroids closer in tend to be drier and a lot more silicate type rock. But that's very much a generalization. So when you look at how the distribution of the asteroid belt is, you would think that it's mostly those outer main belt asteroids that migrated into the Trojan regions, but we don't know for sure. And there are other forces involved that could actually, send some of those inner asteroids out to the Trojan region as well. So that's one of the things that Lucy is going to study is what is the composition of asteroids? What's the mix of compositions, or are they all very similar? That's what we're trying to find out.
Yeah, thank you. It's very interesting.
Yeah. And there's, speaking of asteroids, there's yet another launch coming up in November from Vandenberg Air Force Base here in California. And that's the DART mission, double asteroid redirect. I forget what the T stands for. Anyway, it's a mission to test the concept of deflecting an asteroid using what's called a kinetic impactor. So this is a spacecraft that will fly out and rendezvous with a near-Earth asteroid that's actually a binary asteroid system. So it's got a big asteroid with a little asteroid orbiting around it. And the idea is that they're going to go out to this asteroid and they're going to shoot a bullet basically at the little asteroid. It's a big, a heavy weight that they're going to fire at it at a fairly high velocity, with the idea of testing the idea that we can use a kinetic impactor to slightly alter the orbit of an asteroid. And the reason they want to do this is that this is one of the techniques that has been proposed for protecting the Earth from a future asteroid impact. If we were to discover an asteroid that had the Earth in its bullseye target, and if we discover it soon enough, we have the potential to send a spacecraft up there and deflect the asteroid. And if you do this soon enough, like years in advance of the impact date, it takes only a very small amount of orbit change to cause it to miss the Earth. Whereas if you wait until just weeks or even months before impact, it takes a much bigger change. But if you catch it, 5 years before impact, it takes a very small trajectory change to cause the asteroid to miss the Earth instead of hit it. And so this is a way of testing one of those technologies for doing that. So it's called the DART mission, and it will launch from Vandenberg Air Force Base in, I believe, around the 22nd or 23rd of November. So something else to look forward to.
Sounds like a field trip.
Yeah.
To watch it launch.
Go down and watch the launch.
Yeah. Yep. Watch it from Oxnard or something.
There you go.
Yep. All right. Well, we have time to answer questions tonight. It might be a short night compared to some others, but if there's any questions out there, please feel free to put them down on the Facebook chat or on the YouTube chat.
Yeah, I just saw one on YouTube. Somebody asked, is Jupiter the only planet that has Trojan asteroids? And it turns out no. In fact, the Earth has a very similar phenomenon, although the Earth's gravity being a lot weaker, we don't collect as many asteroids as Jupiter does. Jupiter's got a lot of them out there, but we have also detected Trojan asteroids for the Earth as well. So,
and I imagine that there are some for Saturn and Neptune and Uranus, large gas giants. It's really a characteristic of the orbital dynamics of a massive body orbiting another massive body, and so and because of Jupiter's large mass, that's why its Trojan collection is so prominent, right? Because it's got a bigger and deeper Lagrange point than the Earth does.
Now, Colleen asked a question about string theory, and I'm not sure what she's referring to.
Trying to find the question here.
Yeah, it's on YouTube, and she asked about string theory, and I'm not sure how you're seeing string theory out of all this. None of what we've been talking about thus far relates to string theory.
String theory is getting into the fundamental nature of some of the forces we're describing, gravitation and energy. And you can describe all of these fundamental forces using string theory, but what we're describing is plain old Newtonian mechanics here. And nothing. This is mathematics and phenomenon that have been understood quite well since the 1700s.
Right. Now, Alan Roche just mentioned that someone captured a asteroid hitting Jupiter. We actually featured that last week. We showed some images of that asteroid impact on Jupiter. Jupiter's got a very strong gravitational field, and if an asteroid gets too close to it, it gets sucked right in. And so there was actually several amateur astronomers, mostly amateur astronomers, who happened to be filming a transit of one of the moons of Jupiter. And just at that moment is when they saw this impact occur. I don't have the image anymore, but that was something we talked about last week. We showed the images last week.
John, somebody, who was it? Colleen asked, how is the rocket fueled? I presume you are talking about the rocket carrying the James Webb telescope. But basically, they're going to be delivering all of the stages of the rocket to French Guiana unfueled, right? It's all kind of disassembled. And then they have a vehicle assembly building in French Guiana where they will stack up each of the pieces. The last piece that's stacked is the capsule containing the space telescope, and then they will move it out to the launch pad, much like they do with the U.S. space program, and they will then fuel it with liquid oxygen, liquid hydrogen. And there might be you're going to have to remind me, Gerald, if there are also solid boosters associated with the Ariana.
Yes, Ariana has two solid boosters on either side.
Yeah, so those are pre-fueled, and they're solid rocket boosters. They're called Roman candles, and for a reason. Once you start them, there's no way to stop them, and those are bolted to the side of the rocket and give it the necessary boost to escape Earth's gravity and get into Earth orbit.
Yeah, the liquid fuel is liquid oxygen and liquid hydrogen, and that's the main engine part. But on the side of the main booster body, you'll see a couple of extra rocket motors, much like the space shuttle had. And these are the solid rocket motors. It's ammonium perchlorate and aluminum powder. Very explosive mixture. You don't want to be around when they're loading those. It can be pretty dangerous.
Yeah. The other thing is the James Webb Telescope itself also has small rockets on it to adjust its attitude and the direction it's pointing. It has to be very carefully positioned so that one side is always facing the sun and the other side is always facing deep space. And one side of that telescope is going to be something like 200 degrees Kelvin, very, much hotter than the other side, which will be next to almost 0 degrees. So there will be a 200 degree difference between one side and the other, and they'll have rocket motors on the telescope to make sure that orientation remains constant.
Yeah, Colleen asked if that's what they mean by solid rocket boosters. Yes, it is. Yeah, the SRBs that they had on the space shuttle, those were the solid rocket boosters.
Good questions.
Yeah.
Thanks.
Yeah.
Sabrina, I don't know off the top of my head of other exciting missions beyond 2021. Gerald probably does. What other rockets are in rockets? What other satellites are in the works right now?
One that I'm kind of looking forward to, and it probably won't launch until around 2023, and that's the NEO survey mission, sometimes called NEO-SM. NEO stands for Near Earth Object. This is a program that has been in front of NASA for years. Right now we discover asteroids almost exclusively using ground-based telescopes here on Earth. The trouble is that really limits your ability to discover asteroids. You can only look at night. You can only look to the part of the sky that's away from the sun. You're limited because of the atmosphere. You can't see the fainter asteroids or the ones farther away. So there's a lot of limitations to the current method for discovering asteroids. And because of that, there's still a lot of near Earth asteroids we haven't found yet. In fact, it's possible there's more than 1 million of them out there that have not yet been found. I think we've only found about 27,000, 28,000 so far. So, and we think that there's at least 1 million of them out there. So there's a lot yet to be discovered. For many years, people in the asteroid discovery business have been pushing NASA to fund a program. It used to be called NEOCAM. Now it's called NEO-SM. And this is to put an infrared camera in space in an orbit that allows it to see a much wider field of view than what we can view from the Earth. It's not restricted to just the night side of the Earth. It can also look to within about 20 degrees, 25 degrees of the sun in either direction. So it's going to cover a much wider range. It will be infrared, which makes it actually easier to see asteroids, even if they don't have a lot of light reflected off of them. Right now, when we discover asteroids, we discover them by seeing reflected sunlight off the surface of the asteroid. Well, with infrared technology, you don't have to see direct reflected sunlight. All you have to do is see an asteroid that's warm enough to emit infrared, and that's a pretty cold asteroid, can still emit infrared, and you can use that to discover asteroids. So this mission is going to significantly increase the number of near-Earth asteroids we discover. We're going to discover them a lot sooner than we do right now. Most of you may not realize this, but every month, near-Earth asteroids pass the Earth closer than the moon several times a month, typically somewhere around 8 or 9 times a month. We get an asteroid whizzing by the Earth closer than the moon. Now, the distance to the moon is still pretty great. It's about 240,000 miles away. You can actually fit 30 Earths in that space. But still, it gives you an idea of how close asteroids come to the Earth pretty regularly. The thing that's kind of disheartening about that is that almost all of these near-Earth asteroid close flybys are asteroids that were discovered within just a couple of days before their closest approach to the Earth. So, we were talking earlier about missions to go out and deflect asteroids before impact. You got to discover them years before impact for that technology to work. Right now, the technology we have, for the most part, doesn't see those asteroids until just days before, and sometimes a couple of days after their closest approach. So we need to improve on that a lot, and that's what this NEO survey mission is all about. And again, that just got approved by NASA. Finally, they've gone ahead and funded it to go to the next level. It's always been funded at a very low level, just enough to research the technology, but not enough to get the thing built and launched. And NASA has finally committed to doing that.
We've got a few. Thanks, Gerald. I've got a few other missions that I've discovered for 2022 that are interesting. There's actually going to be 2 missions to the moon next year. One by NASA.
Viper.
Yeah, one by NASA and one by the Russians. So looks like we're getting back into our space race. No, the smart lander for investigating the moon, SLIM, is a Japanese space agency mission where they're going to be testing AI landing techniques. where there's, the computer systems on board are going to actually be able to judge the best landing trajectories and avoiding obstacles, just to figure out more modern ways to control spacecraft during landing. And then the Russians are doing a scientific mission, and I'm trying to find the third one for that NASA is very much
I
more
believe that's the
involved in.
Viper.
Is that the Viper one?
I think it's the
Actually
Viper.
it's a rover, and it's going to
Right.
be studying
Yeah, that's Viper. Yeah.
the deposits of lunar ice.
Right. Yeah. So they just announced within the last couple of days the crater that they're going to. It's a South Lunar Pole crater that they're going to, where the crater is situated such that part of it never sees sunlight, and so they think there's ice deposits there. So that's called Viper, and much of the development of Viper is being done at NASA Ames Research Center, which is the new partner for the Chabot Space and Science Center. So
Yep, that's right. We have a question from Jim. What's the life expectancy of the Webb telescope? Roughly a decade.
Yeah.
Roughly a decade is the desired life expectancy. It says basically they say no less than 5.5 years. We'll see. Probably no more than a decade. It's going to be limited by the fuel that I was describing. Those rocket engines to control the attitude of the instrument are going to be critical. If they run out of fuel and the wrong end points to the sun, it becomes pretty useless. So, and plus you're not going to be able to point it properly after that. So it is limited by the fuel, and of course there's no way to refuel it. So we hope a decade, right? And,
well, I hope so.
we'll start the betting pool soon.
Yeah.
We have another question. Is humidity an issue for all telescopes? For non-space telescopes, yes. I would say yes. Yeah. And even our small amateur telescopes, humidity is an issue. And there's all kinds of goofy products you can buy for your personal telescopes that control humidity, and by heating up the primary lens or the primary mirror so that it doesn't collect dew.
Which also unfortunately affects the image quality,
right.
But that's another subject.
Right. That's right. So, I try to avoid those. I find them to be very frustrating to strap on and use.
It's pretty easy to understand what's going on. All you have to do is come out some morning to your car, and it's been a cool night, and there's a little bit of moisture in the air, and you got condensation on your windshield. It's not frozen. It's just little tiny water drops all over your windshield. And of course, you're not going to drive with all that condensation on the windshield, so you wipe it off and then get in the car and drive away. Well, we don't want to be out there wiping off the primary mirror of our telescope, so we avoid operating it in conditions where that condensation is likely to form.
That's right. It's not the job creation program we want to have around here. Michelle asked, "Have either of us been to a rocket launch? Have you?"
Yes, I have.
You have. Which one?
Down at Vandenberg, I saw a Titan missile launch at Vandenberg. Very loud.
Very loud, and the ground shakes.
Yes, and the building
quite
shakes.
Impressive. Yes. I saw a Titan launch at Cape Canaveral from Titusville across the channel from the launch pad, and a bunch of people were gathered at the beach. It was a classified spacecraft, a spy satellite, and they didn't give it the go-ahead and announce publicly until just a few hours before the launch. And I had been giving a presentation at Cape Canaveral earlier in the day. I was helping with an Oracle presentation to some of the IT folks who were at Cape Canaveral, and we got word that they got the go-ahead for the launch. So I got in my car and I drove across to Titusville and sat around on the beach with a bunch of other people waiting for it to launch, and it launched, and it was incredibly impressive. And this guy who was driving this pickup truck and looked up, and he yelled out at the top of his lungs, "I'll never complain about paying my taxes again." I'll never forget that. I was on the floor laughing. It was such a funny moment. But yeah, they're very impressive. If you ever have a chance to watch a launch, do it. They're great.
Yeah. I was at Vandenberg Air Force Base. I was in the middle of a security briefing with a bunch of other guys, and we were inside a conference room inside the building. And I thought it was an earthquake because all of a sudden the ground shook really hard. But the guy that was doing the briefing, he knew right away it was a launch. And he says, "Oh, they're launching." And everybody ran outside. And of course, by then it was so loud you couldn't hear yourself think. And we all watched it climbing up into the sky. So it was pretty impressive. A lot of smoke.
Yeah, there is that. All right. Well, we had a lot of really good questions tonight.
Yeah.
Let me just give a check on YouTube real quick to see if there's any others. And there we go. Gotta get to the right page here. I don't see any more on YouTube.
Yeah, Colleen made a comment about RTGs, and I need to explain about RTGs. RTG stands for radioisotope thermal generator. That's a device for generating electricity. It's not for maneuvering the spacecraft. So the electrical power on a spacecraft or a rover or something like that, one way of getting it is using an RTG. Spacecraft that orbit the sun relatively close to the sun, say a spacecraft orbiting around the Earth, the geosynchronous satellites and so on, they get most of their power from solar panels, just like the solar panels that you have on your roof. But spacecraft that go farther out away from the sun, where the sun's energy is weaker, or that land on other planets like rovers on Mars, those may use RTGs to generate electrical power instead of using solar panels.
Well, they could also use an RTG, I believe, for ion propulsion, right?
Well, if you're going to do ion propulsion, yeah, you need a source of electrical power, right? And a good example is the Cassini spacecraft went out to Saturn, much too far away for using solar panels to generate the power. So it was equipped with RTGs to generate the electricity. The two rovers on Mars right now, Curiosity and Perseverance, both of them use RTGs. And an RTG is just a device that has these little plutonium pellets inside of it. The plutonium is going through radioactive decay. That radioactive decay generates heat, and then the system uses the heat from the radioactive decay to generate electricity. So it can last a very, very long time. It's and not the most efficient way of generating electricity, but it has the advantage of being able to last a long time, and you can use it day and night. So that's an RTG.
Stephen is asking if we can elaborate on the educational programs that are going to be available at the new Chabot exhibition in partnership with NASA. And you'd be the best person to talk about that, Gerald.
All right. Yeah, there's quite a bit. The main new exhibit area that they're working on right now is going to showcase a lot of what goes on in NASA, in particularly at NASA's Ames Research Center, which is here in the San Francisco Bay Area. One of the features that you would see if you went to Ames Research Center is these very, very large wind tunnels. These things are gigantic. And one of the things that we're going to have in our exhibit is actually one of the fan blades from one of the wind tunnels. And it will give you an idea just how big that wind tunnel is. There's also going to be a whole section on robotics. One of the other things they do at NASA Ames Research Center is work on AI and robotics and so on. So there's going to be a section in there, and there's actually going to be a little bit of an exercise. One of the educational programs is going to be build your own robot, and we're going to have a sort of what we're kind of tentatively calling a Mars yard, although I think they're eventually going to give it another name, but it will be a place for you to take your rover out and actually test drive it and so on. We're going to have our completely updated Mercury capsule simulator is going to be in the exhibit, and quite a few other things. And it's not going to be static. It's going to change over time. So every few months, we're going to change the content to emphasize other projects that are going on at NASA Ames, plus, just our general focus on science education. That's one of the main missions of the Chabot Space and Science Center is science education for the public. We are going to be doing programs for local schools, bringing school kids up to Chabot and taking Chabot programs to the local schools. So a lot going on over the next year, but we have to wait until November when we officially reopen. And of course, one of the great things about when we reopen is we can once again resume public viewing through the Chabot telescopes. So you won't just have to wait until Saturday night to watch these two clowns or three clowns, however it is. You can actually come up here
collect,
and meet us in person and, be disappointed and say, he looked a lot taller on video. Right?
He looked a lot taller on radio?
On the video.
All right. Well, Sabina asked, what kind of rockets take the probes out to space? Ariana is one.
Yeah.
And what are the others, and who makes them, and do countries collaborate on this? Well, the Ariana, the one you mentioned, is really European Space Agency, which by definition is a collaboration of countries. The other major classes of rockets are either individual countries or SpaceX, right? SpaceX has the Falcon rocket.
Falcon 9s, there's Atlas.
Right.
Atlas
NASA
rockets.
uses the Atlas, the Delta, the Pegasus, the Taurus, and Russia has its own series of rockets, and China has its own series of rockets. And they're less collaborative than the ESA. But,
and then there are some smaller rockets too. Blue Origin has their rocket that they use. A couple of other smaller companies, for strictly research. These don't carry probes to other planets and things like that, but they do research, suborbital flights, things like that.
Or tourists.
Yeah.
The latest trend. All right. Well, very good questions tonight, everyone. Thank you. That helps. And against all odds, we've managed to fill another hour. Or
really? Almost an hour. Yeah. Well, I guess we can, give it another 5 minutes here and then wind it up.
Yeah.
And hope for next week that we'll have clear skies. We're getting into the fall. That's usually the best season for us in viewing. There's one thing I wanted to make sure everybody is aware of. October 16th, which is a Saturday night, is International Observe the Moon Night. So we will be doing almost exclusively moon observing that night, talking about the moon, talking about the features we see on the moon, and hopefully actually pointing our telescope at the moon and letting you see that and talk about it and so on. So something to look forward to. And this, like I say, this is an international event. So quite a few observatories and science museums will be doing programming around that theme.
It's a night for lunatics, Gerald.
There you go.
So I got to tell you, if you want to learn about the moon, tune into our program because Gerald has an almost infinite reservoir of knowledge about the moon, and I've learned so much from him about the moon. So you should definitely plan on joining us.
All right. Anybody else have any questions they want to fire away at us? Now's the time.
Or forever hold your peace.
Yeah.
How long will the ISS remain in orbit? Well, that's a good question,
Yeah.
especially after the news from this week. There was a congressional hearing where one of the designers of the ISS was saying, those cracks they keep telling us about, I'd be more concerned about them than they're letting on. And he publicly testified that the increasing number of cracks in the ISS are of grave concern. NASA has released information contrary to that, saying these are not really that serious. And so there seems to be some difference of opinion among experts. And the conservative view would be, hey, if you're uncertain about whether something is deadly, you have to assume it's deadly. So it may be that the ISS is going to be a source of controversy.
Yeah.
We'll see what happens.
I have a friend who is the number 3 guy at NASA. And I was talking to him the other day. I asked him about the space station, and he says, as far as they're concerned, NASA will continue operating it until 2025, and thereafter they're going to transition it to become a commercial space station. So commercial entities will continue operating it. So
they may have to ditch some of the modules that are misbehaving.
Right. And they just brought in a new one. There was a brand new Russian module that just docked with it here, I think, a week ago.
That's right. That's true. And the one that's been experiencing the worst cracks is also a Russian module. So we'll see. So hold that thought, Stephen. Nobody knows.
Yeah, we'll see. There's plenty of other modules on the spacecraft, though. So.
Yeah. And if there is one section that's problematical, they could always reconfigure and decide to ditch part of it if they need to. So, all right.
Okay.
That's it for tonight.
Well, we look forward to seeing you again next week. Once again, we want to remind you, Chabot is closed right now, but we are relying on donations from people who are watching this program and corporations. If you know of any corporations that would like to sponsor Chabot, you can go to the Chabot Space and Science Center website. It's chabotspace.org, and you can click on the donate button at the top of the web page, or you can find your way to the membership page and join up as a member. There's also a page there for corporate sponsors to get more information about doing that. Certainly encourage you to do that. And of course, also, if you're on Facebook, you'll see the donate button on the comment section. Help us out whatever way you can. We appreciate it.
All right. Well, good night, Gerald.
Good night.